Hello and welcome to Okube, an organization building open source solutions for data intelligence. Today, we're diving into the Databricks AI Playground with a special focus on how you can bring your own LLM into the mix. This recently released feature from Databricks has been a hit, allowing users to chat with and compare multiple models, all within their workspace. But what's flown under the radar is the ability to bring your own custom model into the playground and compare its performance against other off-the-shelf LLM. That's exactly what this demo will cover. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. To access Databricks AI Playground, simply log into your workspace and click on Playground in the Machine Learning section. You are presented with a familiar chat interface. From there, you can start having a conversation with one of the selected LLM models. Playground party trick is the ability to add a second model and compare the results. That's great, but where are these models coming from? Heading over the serving panel reveals a list of models that are made available by Databricks. Some, like DBRX and Llama, are general purpose, while others are more specialized. Models available in the playground are flagged as chat models. Let's try to create a new custom chat model and use it in the playground. Let's head over a notebook to build and register our model. The strategy is quite simple. Use LangChain to build a chat and register it using mlflow. LangChain is a popular framework for building chats. It offers a layer of abstraction over specific LLM and allows to chain operations. Here we use the chat Databricks class to use DBRX instruct as our LLM. Then, we create a simple prompt acting as a Databricks exams certification assistant. Finally, we combine them in a chain that we can chat with. As expected, the chain acts as the certification assistant we defined in the prompt. Now that we have our chain defined, let's use mlflow to create a model and register it to Unity Catalog. Models are generally derived from the Python model base class. Let's give it a try. All we have to do is to create a predict method that will pass the model input to our chain and return the result. Next, we need to register our model to Unity Catalog. Let's name it Databricks1 and assign it to a given catalog and schema. The log modal method within the context of a model run will register the model and assign it a version. Peeking at our model's registry, we can see that Databricks1 has been properly defined and version 1 has been created. We can now load our model from the notebook and test it by providing some user inputs. Notice how the input received by predict method is a data frame. If you are not familiar with mlflow, this might be surprising, but it's the default behavior. The inputs you provide are converted to a data frame to run multiple predictions at once. This is not particularly well suited for a chat model, but we can still make it work by apply some transformations to the input object before sending it to our chat. Now that we have a working model, we can serve it and hopefully bring it to our playground. Let's create a serving endpoint and select the model we just registered to Unity Catalog. Our endpoint is ready. This makes it easy to call our model from outside Databricks using Python or REST API. Let's see if it's also available from the playground. As you can see, Databricks1 is nowhere to be found. This is because our endpoint is not a chat task. For that to happen, we need to create a second endpoint that refers to the first endpoint as an external model. This is quite counterintuitive, but we could not find any better solution than to create two endpoints. If you have a simpler solution, please add in the comments below. We now have the option of defining our model as a chat task. Now that this second endpoint is ready, let's head back to the playground. And voila! We can now select our custom model and start chatting. Oh, it looks like we are not out of the woods yet. Invoking our model resulted in a bad request. This is because a very specific signature is expected from the model when chatting in the playground. Let's go back to the notebook and create a new model that meets that signature requirement. The solution is actually quite straightforward, but is not extensively documented. The key is to derive from the chat model base class instead of the Python model. This class automatically sets the signature to be compatible with OpenAI and Playground chatbots. We also need to refine how our output is formatted. Beyond that, the process is essentially the same. For clarity, we name this new model Databricks 2. Let's go ahead and register the model. If we want to test it, we need a different structure for our input. Notice how this time the object received by the predict method is not converted to a data frame. Instead, it's an object better suited for managing conversations. Alright, now we are ready to serve this new model. The process is exactly the same, except that we select Databricks 2 instead of Databricks 1. And again, we create a second endpoint from an external provider. Fingers are now crossed to be able to chat with this model. No luck, it still results in an error. This time, it's the default temperature of 0 that can't be processed by our model. Who is expecting a floating point value? We have never been able to find a solution other than setting the temperature to a small non-zero value. Finally, we have a working chat bot that is Databricks Playground compatible. You can now initiate a conversation and let all the users of the workspace do the same. You could also compare the results to other built-in foundational models. That wraps up our demo on creating a custom chat bot for the Databricks AI Playground. Once you've got the process down, it's fairly straightforward. But there are a few tricky, undocumented details that can easily eat up your time. We hope this walkthrough was helpful and makes it easier for you to build custom chat models. Have you tried out the AI Playground yet? Or do you have an even simpler solution for integrating custom models? Drop your thoughts in the comments below, and we'll see you next time.